Okay, so in this video we'll be going over periodic functions. Periodic functions are just step functions that occur multiple times. An example would be this graph, where we have a line of 4t over 2a because our function is essentially just a line with a slope of 4t divided by 2a because slope is rise over run, and it occurs multiple times over a period of 2a. So every 2a, the step function repeats. One period is known as a window. A window is one pattern in the periodic function, and it can be represented as a step function, like we did in the previous chapter. So let's do that here. So we have this rise is 4t over 2a distributed to u t minus 0 minus u t minus 2a. And that's how we'd represent that one window. So continuing with this chapter, let's do number 25. Number 25 is asking us for the Laplace transform of this function, which was the same function we used in our example. Well, to find the Laplace transform of a periodic function, we need to know a formula. And the Laplace transform of a periodic function is equal to the Laplace transform of the first window divided by 1 minus e to the negative st. Well, we know the first window is a step function, and we did this before, so let me just rewrite it. The step function of the first window is 4 divided by 2a, or so 2t divided by a distributed to u t minus 0, which is just 0, minus u t minus 2a. Okay, we need to recall this formula. The Laplace transform of a step function is equal to this. So g of t is this function here. So we have to say g at t plus tau. Well, tau here is 0. So it's just the Laplace transform of 2ta, which is the same as 2 over as, because this is just s squared, sorry, because this is a t, and then that's times e to the negative s tau. Well, e to the negative s tau is just e to the negative s times 0, which is just 1, because there is no tau here. So we can move on to the next one. So we're going to have minus 2 over a. Now we have to replace, we do have a tau here, right? We have minus 2a, that's our tau. So we have to replace t here by t plus tau, because that's what our formula says. So instead of t, we're going to have t plus 2a, because that's our tau, times e to the negative s 2a. So let me write that, negative 2 as, because that's our formula. Okay, we're not done yet though, because we still have t, so we have to find the Laplace transform of this, because that's what the formula says. No, it doesn't. I need to write that. The Laplace transform of that, well, this whole function would be 2 over as squared minus 2 over a. The Laplace transform of this is just 1 over s squared plus 2a over s, because that's just a constant. A is just a constant, rather, 2as. Okay, and now the last thing we need to do is divide by this. So 1 minus e to the negative st, but in this case t will always be the period. And the period of this function is 2a, because every 2a, this step function repeats. So we're going to end up with negative 2as. And this is going to be the answer. Theoretically, we could simplify this a little bit more, but there's no need. My math lab will accept the answer. So we'll just leave it like that. So this is how you would do number 25.